Okay, one more example. This time we've got an investment mixture problem. Monty Burns would approve. So an investor has a total of $15,000 deposited in 3 different accounts in which earns an annual interest rates of 9%, 6%, and 4%. The amount in the 6% account is $2,000 more than the account in the 4% account. So if the 3 accounts earn a total of $980 in interest, how much is deposited in each account? Okay, before we start diving in, the very first thing, as we've been saying in each of our examples, is that if you are going to solve a system of equations, or if you're going to set up a problem to solve, you have to identify some variables. So we start from the back end. What are we actually being asked? Well, how much are we actually putting in each account? So let's look at our amounts here. Let's try this here. Our amounts, I'm going to use a different color here. Our amounts, let's see, we've got 3 different accounts, right? So let's put, I don't know how many dollars in each account. So let's use our X, Y's, and Z's again. So we're going to put X dollars and invest it at 9%, right? And we're going to take Y dollars and we're going to invest it at 6%. And we're going to take Z dollars and we're going to invest it at 4%. So now the question is, all right, how do we actually find those values X, Y, and Z? Well, okay, what do we know? Well, for one thing, we know that we have a total of $15,000. So whatever X, Y, and Z are, we know we're given right away a situation where, it's supposed to be a, I'm having too much fun today, kids. All right, given that X plus Y plus Z, the total amount should equal $15,000 when we put that all together. So we're going to put our 15,000 here. Now the next amount is, well, what do we do with all of these things? Well, we also know that there's a relationship here between the 6% account, Y, and our 4% account, Z, right? And it says that whatever amount we put in our 6% account is $2,000 more than what's in our 4% account. So right now, we could also say that the amount Y that we have is exactly equal to the amount that we have in Z plus $2,000, right? So that is actually going to help us out a little bit. But then we have this third part right here. What, I mean, if we've got 3 variables, we should have 3 equations. This is certainly not enough to get X, Y, and Z out, so we need a third equation. And that's where the interest comes out. Remember your simple interest formula. It goes like this. The amount of interest in an account is equal to the principal times the rate. Yes, okay, Monty Burns approves. So interest is equal to principal times rate, so we should set up a table right here. This is probably a good place for it. So let's see, how much have we got in each of these accounts? Well, we're going to take the principal in each account. We're going to take the rate in each account, and we're going to get the interest in each account individually, combine them together. So we had 3 accounts. In our first account, we put in X dollars. In our first account, it's at 9% interest, so 0.09. And when we multiply those together, we get our interest. In this case, that's 0.09x. What else do we know? Well, we've got Y dollars in the second account. And we're going to multiply that times our rate. We have to write our percentage in decimal form, so 0.06, and that gives us 0.06 times Y as our interest amount. Z, which is our amount in the 4% account, is going to have to be multiplied by 0.04 to give us 0.04Z. And of course, you know the way that this one works. We say that when we add all these things together, we get the total interest, which in this case is $980. Okay, well, what could we do with that here? $980, good Lord. Well, what we're going to do is we're going to work this one through, and we're going to say, well, if this is the case, then we have a third equation that goes like this: x times 0.09 plus 0.06 times y plus 0.04 times z is equal to 980. Well, when that's the case, what do we do? Well, I don't like these decimal places over here, right? All these decimals in here. What could I do? Well, I'd have to multiply everything by 100 to rewrite these numbers in something. So I'm going to multiply both sides of this equation times 100 so that I get rid of those decimals, you know, because having so many decimals around, again, I can do it, but it's really, really time consuming, and I'm sure you would like to save the time as well. So if I multiply 100 times each term on the left, I get 100 times 0.09 is just 9x. 100 times 0.06 is plus 6y here now. And 100 times 0.04, that's going to be plus 4 times z. And that will equal a total amount of 980 and 2 more zeros from the 100. So 98,000. All right, now what else do we know? Well, now we've got a relationship. We can actually make a system of equations in two variables by taking this replacement for y everywhere we see y and then rewriting our equation. So now it's rewrite time, right? We're going to use y equals z plus 2,000 to rewrite each of these equations and get a nice system of equations in two variables. All right, so we do that. Let's see. In the first case, if we take x plus y, that's now x plus z plus 2,000 plus z, that's going to give me 15,000. Which modifies as x plus 2 times z plus 2,000 equals 15,000. And so I can subtract here, and I'm going to get x plus 2z equals 15,000 minus 2,000 gives me 13,000. All right. Now I'm going to have to do the same thing here with my second equation. So I'm actually going to have 9x plus 6 times, in this case, z plus 2,000 plus 4 times z equals 980,000. So I'm going to have to simplify right here. 9x plus 6z plus 6 times 2,000 gives me 12,000 plus 4z equals 980,000, pardon me. So when we do a little bit of work right here, what's going to happen? Well, 9x will have, for this one, I'll put it under here, 9x plus 6z plus 10z, that gives me plus 10z, plus 4z gives me plus 10z, pardon me. Then I would have to subtract 12,000 from 98,000. Well, that's going to give me 98 minus 12 gives me 86,000. And now I've got my system of equations. And this is the one I'm going to solve for x or y. Well, what's the easiest thing to do? I would say that if I take equation 1 right here and equation 2, and I solve this system right here, it would probably be worth it for me to multiply the first equation by, well, let's get rid of the z's. Let's make it -5 times equation 1. plus equation 2, that's going to eliminate z. All right, so what happens here? Negative 5 times x in the first equation, minus 5 times 2, that's negative 10 times z, equals negative 5 times 13,000, that's negative 65,000. We're adding that to 9x plus 10z equals 86,000. So now we're going to add these up. We're going to get 4x equals, let's do our subtraction right here. These are all going to be zeros here. 0, 0, 0. 6 minus 5. I'm going to subtract up. So pretend we're subtracting up. 6 minus 5 is 1. 8 minus 6 is 2. So 4x equals 21,000, which means that we're going to have to divide everything by 4 to figure out what this one is. All right, well, that's going to give us x is equal to 4 goes into 21. We know that's going to be 5 times, but that's going to leave us with a 1 left over, so that's going to bring down the 10. So 4 goes into 10 twice, giving us 8. Right? Maybe I should write this out here. 4 into 21,000, so you guys can see it. 21,000. 4 goes into 21 5 times, giving you 20. Subtract, bring down, we got a 10. That's twice. Subtract the 8. Bring that down. That gives you a 2. 4 goes into 25 times. 5 times 4 gives us 20. Of course, that subtracts away now and gives us 0. Bring down the 0, of course, 0 right here. So we're going to have x equals $5,250 for x. Now we can go to our different equations and figure out what else is going on right here. So let's see. We've got x plus z, 2z equals 13,000. So we're going to take 5,250 plus 2 times whatever z is to get 13,000. So let's carry out the subtraction right here. Subtract 5,250 from both sides. All right, subtract 5,250. We're going to get 2 times z is equal to, let's see, 13,000 minus 50. I would need to borrow right here the 3. I'm going to borrow one of those. That gives me a 2. Carry that 10, borrow from that, give me a 9. Borrow from that to give me a 10. So I'm going to have 0, 5, 9 minus 2 is 7. 12 minus 5 would be 7. So I have to divide that by 2. Divide that by 2. 2 goes into 7750. Let's see. Z is equal to 2 into 7750 gives us 3875. I won't bore you with all the details. 3875. Okay, and then of course if we use our top equation right here, or sorry, our second equation, right, y is equal to z plus 2,000. So all we have to do is add 2,000 to this to get our other investment, right? So y is equal to 5,875. And so we would say that in each of our accounts, we would be investing 5,250 at 9%. We would be investing $5,875 at 6%. And we would be investing $3,875 at 4%. All right, good luck on your assignments. I'll see you in class.